The next couple of sections, what we're going to do is examine the solution to story problems. Before we actually get into solving story problems, you need some prerequisite information. And the first thing you should be able to do is translate verbal information into a mathematical expression. In doing so, you need to look for key words that tells you which operation or operations will be involved. Now, this list is by no means all-inclusive. These are some of the terms that are most often used in story problems. So if you encounter any of the following words, added to, sum of, more than, greater than, increased by, total of, then somewhere in that translation, verbal translation to your mathematical translation, you'll use the operation addition. Likewise, subtracting from, minus, less than, fewer than, decreased by, difference means that subtraction is going to be used somewhere in your mathematical expression. Multiplication, multiplied by, product of, sometimes simply the word of, twice, double, triple, times. Division, divided by, quotient of, ratio, per. Equality, equals, same as, results in. There are basically 7 steps in solving a story problem. Students generally do not like to employ these steps, and that's why they have difficulty solving story problems. They like to read the story problem and they try to begin in step 5 by writing the equation of the problem that represents what's given in the story problem. Now, in many cases, that's very difficult to do. What you need to do is develop the problem by utilizing the first 4 steps. If you do a good job of developing the problem in the first 4 steps, then the equation emerges from those 4 steps and makes the problem much easier to solve. So I'm going to solve a couple of problems for you, and I'm going to utilize the various steps to show you how easy solving story problems can be. So step 1 is to create an unknown box, and in that unknown box I'm going to use plain simple English, no variables in this particular step, to represent my unknowns. So you ask yourself, what am I looking for? So here's my problem. John wishes to cut 17 feet of wire into 2 pieces, such that one piece is 5 feet longer than the other. Find the lengths of the 2 pieces of cable. So in my unknown box, I'm looking for 2 pieces of cable. So I'm going to write in plain simple English some words that represent the 2 unknowns that I'm trying to find. So very simply put, I have a short piece of cable and I have a long piece of cable. So step 1, create an unknown box in plain simple English. List the quantities that you're trying to find. Now I need to choose a variable, this is step 2, to represent one of those unknowns. So I need to choose a variable to either represent the length of the short piece of cable or the length of the long piece of cable. Now this is not a trivial step, because you can make the problem easy to solve or you can make it more difficult to solve depending upon the choice of the variables here or the choice of the unknown that you choose to represent. In general, always choose the easiest unknown quantity to represent in this particular step. So if you look at this, it says one piece is 5 feet longer than the other. So something funky is going on with the length of the longer piece. So that means that the length of the shorter piece is easiest to represent. So I'm going to choose S to represent the length of the short piece of cable. And again, get away from using X and Y. X and Y are overrated. I generally choose the first letter of whatever the word is that represents my unknown. So S here stands for short. So step 2, choose a variable to represent one of the unknowns. In general, choose the easiest of the unknowns to represent. Step 3, if there is more than one unknown, and here there is more than one unknown, represent any other unknown in terms of the variable that you chose in step 2. So I've got to represent the length of the long piece of cable. Now I don't want to introduce a new variable here, say L, because at this point in the class I haven't taught you how to solve an equation that contains two variables. So I have to represent the long piece of cable using the variable that I chose in step 2, which is S. So the length of the long piece of cable is equal to the length of the short piece of cable, which is S plus 5. So the relationship between the long piece of cable and the short piece of cable is that the long piece of cable is 5 feet longer than the other. So it's 5 feet longer than the shorter piece. So that would represent a length of S plus 5. So again, if you do a good job of developing the first 4 steps, the equation, which is step 5, falls in your lap. Step 4. Express the relationship that exists between the two quantities in plain, simple English, or draw a diagram or make a chart to illustrate the relationship. So here in this problem, it's pretty simple. The relationship that exists between the short piece and long piece of cable is that the short piece plus the long piece, plain simple English, is equal to 17 feet. The whole is equal to the sum of its parts. Now again, if you do a good job of developing the first 4 steps, then the 5th step, which is the most important part, is translating the relationship into a mathematical equation. So I have the short piece plus the long piece is equal to 17 feet. Now, in step 2, I designated the length of the short piece of cable as S. So that's S plus. In step 3, I designated the length of the long piece of cable as S plus 5. So S plus 5 is equal to 17. That's the equation that you need to solve this particular story problem. Now once you have that equation, the rest of it is straightforward, just like we have done in the previous sections of solving linear equations. So S plus S is 2S. 2S plus 5 is equal to 17. Subtracting 5 from both sides, I have 2S is equal to 12. Dividing by both sides by 2, I get S is equal to 6. And you should label this as actually 6 feet. Now, I know exactly what S is because I've defined S in step 2. S represents the length of the short piece of cable, which is 6 feet. Now, the long piece of cable I defined specifically in step 3. The long piece of cable is equal to S, which in this case is 6 plus 5, which is equal to 11 feet. So the length of the long piece of cable is 11 feet. Now step 7, I don't actually show you that. What I say is check the solution against the information that's given in the problem and see if it makes sense. Now notice I did not say check the solution in your equation. I did not say that. And the reason that you do not check it here is if you derive the wrong equation, but you solve the wrong equation correctly, it's going to check out. The left side is equal to the right side, but it may not make sense. So you check the information or the solution against the information that's given in the problem. So I'm going to check this against the information that's given in the problem. First of all, is one of these pieces 5 feet longer than the other? Yes, it is. Does the sum of the two pieces give me 17 feet? And the sum of 6 and 11 is 17. So it makes sense. It checks out. In the next couple of problems, what we're going to do is look at problems that require us to make a chart in order to make the solution or deriving the equation easier. Problems that you will need to make a chart deal with the motion. And there are specific formulas that we use for these particular problems. If it's a motion problem, it deals with rate or speed, if you will. In a motion problem, we're going to use the formula rate times the time is equal to the distance. For example, if you average 60 miles per hour in your vehicle and you traveled for a time of 2 hours, then the distance you would have traveled is 60 miles per hour times 2 hours, which would equal 120 miles. Also, a problem that we are going to use a formula for is that pertaining to simple interest. And again, we'll make a chart, and there are some key specifics that we'll need in that chart, which is the principal, the rate, and the time. So if it's a simple interest problem, principal, which is the money that you invested, times the rate as a decimal. For example, 3% as a decimal would be written as 0.03, and the time in terms of years. So if it's 2 years, the time is 2. If it's 6 months, the time would be 1/2 or 0.5. And you multiply the principal times the rate times the time, and that will give you the interest. Also, we will use a chart for mixture problems, and there's not a designated formula there that works for every particular case. So let's look at the problem that we have here. Two planes leave the same airport at the same time flying in opposite directions. The speed of the faster plane is 100 miles per hour greater than the speed of the slower plane. At the end of 5 hours, the planes are 200 miles apart. Find the speed or the rate of each problem. Hint, this is a motion problem, so we know we're going to use the formula rate times the time is equal to the distance. So we're going to again use these 7 steps for solving this particular problem. So the first thing we need to do is begin with our unknown box. And in that unknown box, in plain simple English, we're going to describe the two quantities that we're looking for. So basically here, what I have, or what I'm looking for, is the speed of the slow plane and the speed, or the rate if you would, for the fast plane. So again, plain simple English. If you do a good job of developing the first 4 steps, then the equation, which is the most important step in the entire process, will fall in your lap. So in step 2, what I need to do is to choose a variable to represent one of these two quantities. And in general, what I do in step 2 is choose the easiest of the two unknowns to represent. So again, what I'm trying to do is either represent the speed of the slow plane or the speed of the fast plane. The speed of the fast plane is 100 miles per hour greater than the speed of the slow plane. So I say to you something funky is going on with the speed of the fast plane. So it's easier to represent the speed of the slow plane. So I'm going to say the speed of the slow plane is simply equal to s. And s here stands for slow. So in step 3, if you have more than one unknown, and I do, I have two unknowns here, you have to rewrite the other unknown in terms of the variable that you chose in step 2. So what I have to do is to represent the speed of the fast plane. And again, I do not want to choose a different variable here, say f, to represent the speed of the fast plane. Because at this particular point in time in the class, in this course, I haven't taught you how to solve an equation that involves two different variables. So somehow, I'm going to have to rewrite the speed of the fast plane in terms of the speed of the slow plane. And I have that relationship is given here. The speed of the faster plane is 100 miles per hour greater than the speed of the slower plane. So if I take the speed of the slower plane and add 100 to that, that gives me the speed of the faster plane. Now, anytime you have a motion problem, anytime you have a simple interest problem, or anytime you have a mixture problem, then what you need to do is to make a chart. So I'm going to make a chart here to help me better understand and decipher this problem. So I'm going to need, in each one of these, I'm going to need a column that represents each one of these quantities in my formula. In a motion problem, the rate times the time is equal to the distance. So I'm going to have a column for rate, I'm going to have a column for time, and I'm going to have a column for distance. So here I have the slow plane, and here I have the fast plane. And I used S to represent the rate or speed, if you will, of the slow plane. I used S plus 100 to represent the speed of the faster plane. Time. Well, the time here is 5 hours. At the end of 5 hours, so T is equal to 5. So the distance here, D, is equal to the rate times the time. So the distance will be found by multiplying these two quantities together. So after 5 hours, the distance that the slower plane has traveled is 5 times S. Why? Because the distance, which is D, is equal to the rate times the time. The distance that the faster plane traveled will be 5 times the quantity S plus 100. Again, because this represents the rate and this represents the time. And the rate times the time is equal to the distance. So the last column here is found by multiplying these two columns together. So the slower plane in 5 hours traveled a distance of 5s. The faster plane in traveled a distance of 5 times the quantity, s plus 100. So this is step 4 for a motion problem or for a simple interest problem or for a mixture problem, we're going to make a chart. So you will always make a chart for these three types of problems. Now, I say that if you do a good job developing the first four steps, the equation falls in your lap. Well, this is the distance that the slower plane traveled. This is the distance that the faster plane traveled in 5 hours. So at the end of that 5 hours, they are 2,000 miles apart. So if I take the distance that the slower plane traveled, which is 5s, and I take the distance that the faster plane traveled, which is 5 times the quantity s plus 100, that should equal 2,000. So this is the equation that I need to solve. So that gives me 5s, distribute the 5 here, plus 5s, 5 times s is 5s, and 5 times 100 is 500. So don't forget to distribute the 5 here. So that gives me 10s plus 500 is equal to 2,000. Subtracting 500 from both sides, that gives me 10s is equal to 1,500. Dividing both sides by 10, that gives me s is equal to 150 miles per hour. So again, s you have defined precisely to be the speed of the slower plane. So the speed of the faster plane would be s plus 100, which would be 150 plus 100, which is equal to 250 miles per hour. Now, once you solve for the speed of the slower plane, you have only half of the solution, because here we want to know the speed or the rate of each plane. So I need to know the rate of the slower plane as well as the rate of the faster plane. Now, how do I check this to see if it makes sense? You're not going to check the solution in the equation here, because if you derive the wrong equation but you solve the wrong equation correctly, plugging the value for s back into here will give you something where the left side is equal to the right side, but it might not make sense. So how do I check it? Well, I think that the speed of the slower plane is 150 miles per hour. And I think the speed of the faster plane is 250 miles per hour. So I'm going to check it against the information that's given in the problem. First of all, the speed of the faster plane should be 100 miles per hour greater than the speed of the slower plane. And it is here. And they should be 2,000 miles apart at the end of the 5 hours. So if I travel 150 miles for 5 hours, then that means that the slower plane has traveled a distance of 750 miles. If the faster plane travels 250 miles per hour, at the end of 5 hours, the faster plane should have traveled 1,250 miles. And the sum of these two is equal to 2,000, which is checks out with the information that's given in the problem. In this particular problem, we're going to take a look at computing simple interest. And again, in order to compute simple interest, we will use this particular formula. The principal times the rate times the time is equal to the amount of interest accrued. The principal, of course, is the amount of money that you've invested. The rate is, of course, the rate at which the money is invested. And T is equal to the time in years that the money is invested. Now, again, if we have a motion or a simple interest problem or a mixture problem, we are going to solve that particular problem by making a chart and utilizing this particular formula. But that occurs in step 4, so we have to develop the problem as we did before. So an investor has $400,000 to invest. Now, she needs some of the money in 6 months and the remainder in 1 year. She invests a portion of the money in treasury bonds for 6 months at 2%, and the remainder of the sum for 1 year at 3%. Her investment will earn her a total of $7,000 in interest. How much money did she invest in each rate? And again, we're going to use interest is equal to principal times the rate times the time, or I is equal to PRT. And this is $400,000 here. Okay, so let me make sure that you have that. All right, so step 1 is to create an unknown box and in plain simple English list the quantities here that we're looking for. So what we're looking for is the amount of money invested at 2% and the amount of money that she's going to invest at 3%. So she has 2 pots of money, and the total sum of those 2 pots is equal to $400,000. And she's going to invest part of the money at 2% and part of the money at 3%. So I have 2 unknowns here that I must represent. So in step 2, I'm going to choose a variable to represent one of those unknown quantities. And in general, what I try to do is choose the easiest of the 2 unknown quantities to represent in this particular step. Well, here, one is just as easy to represent as the other. So in this particular case, it really doesn't matter which unknown I choose to represent in this particular step. So I'm going to say let M equal the amount of money invested at 2%. So that's the amount of money invested at 2%. So in step 3, I've got to represent the amount of money invested at 3%. Well, keep in mind that she invested a total of $400,000. So if she invested M dollars at 2%, then she would invest the remaining amount, which would be $400,000 minus M, at the other rate. Again, she has $400,000 to invest. If she invested M dollars at 2%, then she would invest the remaining amount of money at 3%. Well, how much money remains? Well, if she invested M dollars at 2%, then the remaining amount of money would be $400,000 minus M. Now again, in motion, simple interest, and mixture problems, you need to create a chart. And you will have a column for each one of these quantities in the formula that pertains to computing interest. So I'll have a column for principal. I will have a column for the rate. I will have a column for the time. And I'll have a column for interest. And remember that the interest here is equal to the principal times the rate times the time. So the way that I'm going to find what goes in the last column is by multiplying these three columns together. So I have an amount of money invested at 2%, and I have an amount of money invested at 3%. Those are my two unknowns. So, how much money do I have invested at 2%? Well, you define that precisely in step 2 to be M. I don't know what M is exactly. That's what I'm trying to find. The principal, or the amount of money that you invested at 3%, you defined as $400,000 minus M. The rate. How long are you going to invest the money at 2%? Well, at 2%, she invested the money for 6 months at a rate of 2%. So 2% written as a decimal number, drop the percent, move the decimal 2 places to the left, is 0.02. She invested the remaining portion of the money at 3%, which is 0.03. The time, the amount of time that she invested the money at 2% is 6 months. 6 months is half a year, and I'm going to write that as a decimal simply because decimals, I have decimals here, so I don't want to necessarily mix decimals and fractions. And the time that she invested the remainder of the money at 3% was 1 year, so the time is 1. So the interest is equal to the principal times the rate times the time. So to find this last column here, I'm going to multiply the principal times the rate times the time. So to find out how much interest she earned on M dollars at 2% for 1/2 a year, I would multiply these together. So that's M times 0.02 times 0.5. To find the amount of interest that she earned at 3%, the principal is, and you do this in parentheses, 400,000 minus M times the rate, so that's times 0.03 times the time, which is 1. And of course you don't need the 1 here because 1 times anything is that anything. Again, in order to solve these story problems, the easiest way is to follow this outline. So this is step 4, and anytime you have motion, interest, or mixture problems, you're going to make a chart. So now I've got to derive the equation. Well, this is the amount of interest that she earned on the money that she invested at 2% for half a year. This is the interest that she earned on the remaining amount of money, which is 400,000 minus M, at 3% for 1 year. Now, the total amount that she earned from both investments is equal to $7,000. So if I take the amount of interest she earned on the money that she invested at 2% for half a year and add that to the amount of money that she invested at 3% for 1 year, that should give me a total of $7,000 in interest. So if I add the amount of interest she accrued on her investment at 2%, which is this amount here, because the interest is equal to the principal times the rate times the time. Again, the last column here is found by multiplying these three together. And if I take the interest that she earned on the amount of money she invested at 3%, which is this amount here, for 1 year, and add these two together, that gives me a total of $7,000. Because the problem indicated that she accrued $7,000 on those two investments. So now, mathematically, multiply these two together. So that gives me M times 0.01. Now, 1 times anything is at anything, so I really don't need the 1 here. But I do need to distribute this number here. So if I multiply 400,000 times 0.03, that gives me 12,000. And multiply 0.03 by M, that gives me minus 0.03 M is equal to $7,000. Now, collecting my like terms here, that gives me minus 0.02 M, and subtracting 12,000 from both sides. So if I subtract 12,000 from 7,000, that gives me negative 5,000. So again, I combine these two terms, and I subtracted this from both sides. So now I divide both sides by negative 0.02. And negative divided by negative is positive, so that gives me M is equal to $250,000. And that's the amount of money she invested at 2%. Now, if I want to find the amount of money that she invested at 3%, then I simply go back up to step 3, where I precisely defined the amount of money that she invested at 3%. So that would be 400,000 minus M. M here is 250,000. So that tells me that she invested 150,000 at 3%. The last type of problem that we're going to examine is a mixture problem. And again, I cannot emphasize the fact of simplifying these story problems by utilizing these 7 steps. And again, I know that this may be a little cumbersome, at least initially to begin with, but if you utilize and learn these 7 steps, then you can pretty much attack any type of story problem that you encounter and successfully solve it. Again, remember, however, if it is a motion problem, we're going to use the formula rate times the time is equal to the distance. If it's a simple interest problem, we're going to use principal times the rate times the time is equal to the interest. And if it's a mixture problem or any of these other 2 types, again, to simplify it, we're going to make a chart. So here we have what we call a mixture problem. If maple syrup costs $6 per quart and corn syrup costs 80 cents per quart, and they're to be mixed to form a cheaper mixture of 50 quarts at a cost of $2.36 per quart, how much of each syrup should be used. So the maple syrup is the most expensive, the corn syrup is the least expensive, so we're going to mix the two and form a blend, which costs us more than the corn syrup but less than the maple syrup. So I've got two different types of syrup that I'm going to use in my mixture. So again, I'm going to begin with an unknown box. And in plain, simple English, I'm going to describe the two quantities that I'm looking for. Well, it's very simple here. I need to know the number of quarts of maple syrup that I'm going to use in this mixture and the number of quarts of corn syrup. And again, here in step 1, no variables, no numbers. Just simply in plain English, write or list the quantities that you're looking for. Now in step 2, I've got to choose a variable to represent one of these unknowns. Now generally what I do is choose the easiest of the two unknowns to represent. However, here one is just as easy as the other to represent. So I'm going to just say let M equal number of quarts of maple syrup. Again, get away from using X and Y. X and Y are overrated. I try to use a letter or variable that represents the first letter of the unknown that I'm trying to find. Now, in step 3, I've got to rewrite any other unknowns in terms of the variable that I chose in step 2. So I've got to somehow represent the number of quarts of corn syrup in terms of M, the number of quarts of maple syrup. Now remember that there are 50 quarts total in this mixture. So if I use a M number of quarts of maple syrup, how much corn syrup do they use? Well, if there is a total of 50 quarts combined of maple and corn, if I use M number of quarts of maple, then the remaining number of quarts in that mixture would be equal to corn syrup. So that would be 50 minus M. Again, I have a total of 50 quarts of corn and maple syrup combined. If I use M number of quarts of maple syrup, then the remaining number of quarts in that mixture would be corn syrup. So that would be 50 minus M. Step 4 is to make a chart. Now when it comes to mixture problems, you're going to have a row to represent each of your components, plus a row to represent the mixture itself. So your two component parts are maple syrup, corn syrup, and then you've got the mixture itself. So in mixture problems, you're going to have a row to represent each of the components that make up the mixture, which in this case is maple and corn syrup, plus a row to represent the mixture itself. So, how many quarts of maple syrup did I use? Well, I've got that specifically defined in step 2. I used M quarts. I used 50 minus M quarts, which I had specifically defined in step 3 of corn syrup. And in the mixture, I have 50 quarts, period. So this column is the amount. In this column, I'll have the cost per quart. Because all of this deals with the cost of the component parts versus the cost of the mixture. So maple syrup costs me $6 per quart. Corn syrup costs me 80 cents per quart, or 0.08 of a dollar. I'm sorry, 80 hundredths of a dollar. And the total cost of the mixture is $2.36 per quart. So now I need to look at the total cost of each component as well as the total cost of the mixture. So the cost in terms of maple syrup would be the number of quarts of maple syrup that I use, which I don't know, and that's what I'm trying to find, times the cost per quart, which in this case would be $6 times M, or simply 6M. The cost in terms of the amount of corn syrup I use would be the number of quarts of corn syrup that I use, which is 50 minus M, and you need that in parentheses because all of this represents the number of quarts of corn syrup that I use, times 0.80. Because the corn syrup cost me 80 cents per quart. And these are the number of quarts that I use. So the total cost of the mixture is $2.36 per quart, and I use 50 quarts, or made 50 quarts. So the total cost of the mixture would be the number of quarts times the cost per quart, which is 50 times $2.36. So how do I derive an equation? Well, it comes directly from the chart. If I take the cost of the corn syrup plus the cost of the maple syrup, it should equal the cost of the mixture. This represents the cost of the maple syrup that I use in the mixture. This represents the cost of the corn syrup that I use in the mixture. And the sum of these two should give me the total cost of the mixture itself. Again, if I take the cost of the maple syrup, which is represented by 6 times M, the cost per quart times the number of quarts used in the mixture, and I take the cost of the corn syrup, which is 80 cents per quart, and multiply it times the number of quarts of corn syrup that I use, which is represented by 50 minus M. If I add these two costs of the components together, it should give me the total cost of the mixture, which is $2.36 per quart, and I have 50 quarts of mixture. So the equation is found by adding these two quantities together, and it should equal the total cost of the mixture, which is this quantity. So that's 6M plus 50 minus M, that quantity, times 0.80 is equal to 50 times 2.36. So that's 6M, and I need to distribute this quantity. So 0.80 times 50 is equal to 40 minus 0.80 M is equal to 50 times 2.36, which is $118. So collect my like terms here. That gives me 5.2 M plus 40 is equal to 118. Subtract 40 from both sides. That gives me 5.2 M is equal to 78. And of course, if I divide both sides by 5.2, that gives me M is equal to 15 quarts. So that means I use 15 quarts of maple syrup. Now I want to know how many quarts of each component I use. So to find the number of quarts of corn syrup that I used is equal to 50 minus M, which is 50 minus 15, which is equal to 35 quarts. So I use 15 quarts of maple syrup and 35 quarts of corn syrup. Now if you want to check this to see if the answer makes sense, then you simply multiply 15 times 6, which will give you the cost of the maple syrup, and multiply 35 times 0.80, and add those two quantities together, and it should give you 50 times 2.36, which is $118.